someone is on a ride and they're going vertically, okay? And AQ will generally ask a question, when is that person most likely going to fall off their seat, okay? So let's take that from first principle. So we've got an object here. Let's assume that our object, right, of certain mass m is doing centripetal circular motion. So the velocity is like that. The acceleration is towards the center and it's making 90 degrees. The velocity is changing, but the value of it, the scalar quantity, the magnitude of it, which is its speed, is not changing. So we're going to work at what happens when it's at the bottom, at the top, and on the side. All right? So firstly, we know that this is the radius r. The object has got a mass m. And let's apply Newton's second law at that position. So if you are at the bottom, let's identify all the forces. So the first force acting on this object is the weight. Okay? And if this is a whirling bung example where you got a certain mass attached to a string, then there'll be a tension in that string. So the tension goes up. Where is the object accelerating? The object is accelerating towards the center. And this is very, very important to represent like that. The object is accelerating towards the center. Okay? Is the object accelerating? Yes. So what does Newton's second law say? Newton's second law says that, that's the second law, okay? If an object is accelerating, then there should be a resultant force on it. So I'll write that as resultant force. There's a resultant force on it. And that resultant force should be in the same direction as the acceleration. So if you apply it here, the object is accelerating towards the center, T will be positive. And W would be negative. And when it's centripetal acceleration, we write that as mv squared over r. You could write that as mv omega, or you could write that as m omega squared r. They all work the same. Now this, you've already done that before in mechanics, right? So if you think about it, here's an object of mass m, here's a force F1, here's a force F2, and the object is accelerating that way. When you apply Newton's second law, you say that this F1 is positive because it's going in the direction of the acceleration. So F1 take away F2 is equal to ma. Now F1 and F2 is actually your resultant force. We're doing the same thing, but here. All right? So I'm going to label this at the bottom. And you can see that T tension at the bottom is equal to mv squared over r plus w. Let's try and apply that same logic now onto the side. So label our forces. Well, weight is going down, tension is going that way, and that's where the acceleration is because it's centripetal, it's radial. The acceleration is pointing towards the center. And if we were to do that again, F resultant is equal to ma. W doesn't count. It makes 90 degrees. Cos of 90 is 0, so W doesn't count. This T on the side is equal to mv squared over r, little r. So here's our second value or equation for tension. This is our little first one. And the last one I'm going to do is at the top. So if you're at the top, the weight is going down, the tension is also going down, but the acceleration is in the same direction. So you will end up with W plus T is equal to mv squared over r. T at the top is equal to mv squared over r minus W. Now, if you were to compare the tension, it's quite easy to see that tension B is bigger. Why? Because you've got mv squared, they all got mv squared, mv squared, mv squared, mv squared over r. However, this has got a plus W. So T tension at the bottom is greater than the tension on the side, which is also greater than tension at the top. And this is very important. It'll ask you loads and loads of questions. The other case that you may have would be when you've got someone sitting on a chair and they're going round in one of these rides. And they ask you, when is it most likely that a person would fall off? And in that case, T changes to become the reaction force. And you'll find that the reaction force, okay, is the smallest at the top. Because what keeps you onto your seat is your reaction force. And I hope that you're going to use that in loads of calculations. Thank you.